right, guys, today we're going to take a look at some law of sines and law of cosines word problems. So if you take a look here, we're going to do these very similarly to how we set up for our right triangle word problems, in that the same kind of things are going to have to be a part of each one. You need to draw a picture and label it based on the word problem, and then you want to set up an equation to solve, and then you want to have your answer. So the same three things are kind of required for these, except instead of using right triangle trig, we'll be using some law of sines and law of cosines. Now, we may also be using some right triangle trig within the problem, depending on what it is. So we still may use some of those skills as well. So you want to make sure that you are still good with your sine, cosine, and tangent of right triangles, as well as using law of sines and law of cosines. Let's take a look at this first one. Two radar stations 2.4 miles apart are tracking an airplane. The straight line distance between station A and the plane is 7.4 miles. The straight line distance between station B and the plane is 6.9 miles. What is the angle of elevation from station A to the plane? Okay, so let's draw a quick picture. We've got station A and we've got station B, and we've got our plane up here at the top, okay, that's in between them. The radar stations are 2.4 miles apart, so this is 2.4 miles. Now, straight line distance between station A and the plane is 7.4 miles. Okay, straight line distance from station B and the plane is 6.9 miles. What's the angle of elevation from station A to the plane? So this is the angle we're looking for. We're looking for angle A. Now for this one, take a look at what we have. What are we given? We're given all three side lengths. Remember, when we have side, 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 we use law of cosines. So we're going to set up a law of cosines equation in order to be able to solve this one. So let's think about what we have, or what we're trying to find. We want to find angle A. So we're going to set up cosine of A equals, let's go back through law of cosines. Cosine of A is equal to B squared, which would be 7.4 squared, plus C squared, which would be, in this case, 2.4 squared, minus A squared, 6.9 squared, all over 2 times, let's see, what are we at? 2 times B, which is 7.4, times C, which is 2.4. All right, let's go and solve. Again, let's make sure that we are on the correct mode, just to check and be sure we're on degree mode. Good. So let's get started here. Let's type in the top, 7.4 squared plus 2.4 squared. Oops, wrong one. There we go. Minus 6.9 squared. Hit enter, divided by parentheses, 2 times 7.4 times 2.4. That's the cosine. So remember, we hit second cosine, second negative to get the answer from the part before. So now we have our angle. The measure of angle A, which is that angle of elevation at station A, is 68.687 degrees. Okay. So the biggest thing is to make sure you're labeling these correctly, and then look at what case you have. What do you have given to you for your sides or angles, and then which law should you use to try to solve? Let's take a look at another one. A rock climber is part of the way up a climb when he can see both the top and base of a cliff. The angle of elevation to the top of the cliff is 42 degrees. Angle of depression to the base of the cliff is 36 degrees. If the cliff is 2,000 feet high, how high up is the climber? Okay, so we got a guy climbing, right? Well, that should be straight. Let's make that a little bit straighter. There we go. And he's looking over. He can see a cliff. Whew, why can I not draw today? Okay. He can see, this would be the straight line distance from him looking. Okay, horizontal line there. He can see angle of elevation to the top of the cliff is 42 degrees. So I'm going to make this angle 42 degrees. Angle of depression to the bottom of the cliff, so starting at the horizontal and going down, is 36 degrees. And the cliff we know is 2,000 feet high. So we're going to call this 2,000 feet. Let's see what else. How high up is the climber? So we want to know how high up he is. So we'll call that X, which would be the same distance as here. Now, this is a horizontal, this is a vertical. So we do have a right angle. We've got two right triangles there. We also have this big larger triangle. So let's see what we can figure out. If we take a look at what's given to us, we can find the other angles, okay, with this triangle, the top right triangle, we have 90 and 42 already. So if we take 90 and 42 from 180, that leaves 48 degrees for this corner. Look at the bottom right triangle. If we take 90 and 36 from 180, that leaves 54 degrees for this angle. So now we have all our angles. We have one side given to us. So we can't solve for X yet. This is one that's going to be multiple steps. But let's think about if we were able to get this side of the triangle, I'm going to label this Y. If we were able to get that side of the triangle, we could then use right triangle trig to find X, couldn't we? With that bottom right triangle. So let's think about how we could find side length Y. Y is across from the angle of 48 degrees. We have 2,000, which is this entire piece. And then we could find this total angle if we added these two angles together. So 36 plus 42 would give us 78. So that angle is 78 degrees. So let's try setting up law of sines. Okay, we've got, we want to solve for that side. We're going to call it Y over the sine of the angle that goes with it would be 48 equals, we have 2,000 as a side length. And the angle that corresponds to that is this total of 78. So sine of 78. To solve for Y, we're going to have to multiply by sine of 48. Okay, to cancel here. And let's see, let's go do that. So 2,000 times sine of 48, close parentheses, divided by sine of 78. And that gives us 1519.494. Okay, so we found Y. Now we need to find X. We want to find his height, the climber's height. So we need to use right triangle trig with this bottom right triangle. We have this side, which is our hypotenuse. We want to find this piece, which let's look at the 36-degree angle because that's given to us. It really doesn't matter. We could use either one. But let's say we look at 36. X is opposite and Y is hypotenuse. So we know that sine in right triangle trig uses opposite and hypotenuse. So we could say sine of 36 equals opposite X over the hypotenuse Y, which we just found to be 1519.494. So all we need to do to solve for X is multiply by 1519.494. Sorry about that. Let's go over here to our calculator and let's type this in. 1519.494 times sine of 36. And we are going to get X equal to 893.136. So we know that that climber is 893.136 feet up in the air. Now, that's one that is a little bit more work. That's probably your most complicated type because you actually have to do two things. We had to find one side just so we could do some right triangle trig to find that height. So that's one of your most complicated types because it involves multiple different pieces. All right, let's take a look at another one. During a skating routine, Jackie and Paul skate apart with an angle of 15 degrees between them. Jackie skates for 5 meters and Paul skates for 7 meters. How far apart are the two skaters at this time? Okay, so again, let's draw a picture. That's going to help us the most. Okay, so they're starting at the same place. Now, they skate apart with an angle of 15 degrees between them, so it's not a big angle. Okay, 15 degrees. And Jackie skates for 5 meters, so I'm going to put this as 5 meters. And Paul skates for 7 meters. And we want to know how far apart they are. So X is this distance between Jackie and Paul. All right, so let's take a look at what's in the triangle. We have two sides and we have an angle that's included between them. So we have side angle side, okay? That means we want to use law of cosines, right? And we're solving for a side. So we're going to start with our side squared. So x squared equals, remember the pattern, the other two sides squared and added together. So 5 squared plus 7 squared minus 2 times the other two sides, 5 times 7, times the cosine of the angle that goes with the side we're looking for, so times cosine of 15. Okay, remember we can type this in all at once. We can hit second square root, and now we can just type it all in together. 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 15. I'm going to close both. There we go. And we get x as equal to 2.527 meters. Okay, so we know that they are 2.527 meters apart. Okay, and notice that that's a pretty small angle. It's pretty safe to say that this is probably going to be the smallest angle. Robinson, 25520. Sorry, guys. Again, this is probably going to be the smallest angle in our triangle, so it definitely want to be smaller than the other two sides, and notice that it is. So that pretty much lines up. Let's take a look at another one. This one's got two parts. Okay, so we're going to work through this one together. Allison is walking along a straight road. She decides to leave the road, so she walks on a path that makes an angle of 35 degrees with the road. After walking for 450 meters, she then turns 75 degrees and heads back toward the road. Okay, so before I even look at what we're trying to solve for, let's try to draw a picture here. Okay, well, I won't move it down. I'll put it right here. So she's walking on a road, right? So let's say this is the road. I've got a straight road that she's walking on. Maybe if my pen will decide to cooperate. So we have a straight road that she's walking on. Okay, and she decides to leave the road and walk on a path that makes an angle of 35 degrees with the road. Okay, so we'll call this, well, maybe, geez. Okay, 35 degrees. All right, so she's walking 35 degrees on a path that's 35 degrees with the road. And it says that she walks for 450 meters. Okay, and then she turns at an angle of 75 degrees. Now, she's walking facing this direction, right? That's the direction she's walking in. So when she turns 75 degrees, that 75 is right here, okay? Because that's how she's facing. She turns 75 degrees and starts walking. What we have to realize is that when she's turning that 75 degrees, that, like I said, is on the outside of our triangle. So inside, we could take from 180, and that would leave 105 inside the triangle for that angle. Okay. Okay, so we've drawn everything here. 75 outside, 105 inside. How far does she need to walk on her current path to get back to the road? Okay, so we want to know, this is our X. We're trying to find this in part A. We're trying to find how far she needs to walk to get back to the road. And then part B, when Allison returns to the road, how far along the road is she from where she started? So for part B, we want to find this length. How far is she from where she started out? She left the road here, and here's where she's going to end up back on the road. Okay, so I'm going to go ahead and find this other angle just in case we need it. So think about what we have. We have 35 and we have 105. So if we take 180 and subtract 105 and subtract 35, that's going to leave 40 degrees. Okay, so now if we take a look, we want to find this side length. Okay, We could actually use law of sines or law of cosines. I'm just going to set up law of sines because we did law of cosines last time. So I'm going to do law of sines. Okay, take a look. We want to find side x. And we have 35 as the angle opposite. We have 450 as a side, and we have angle 40 as the angle opposite. So let's set this up. X over sine of 35 equals 450 over sine of 40. To solve for x, we're going to have to multiply by sine of 35. Okay, so let's go over to our calculator and do that. We want 450 times the sine of 35, close parentheses, divided by the sine of 40. So we now know that x is 401.547 meters. So she has to walk 401.547 if she walks straight back to the road on that same path at the 75-degree angle. Now, part B, once she returns to the road, how far along the road is she from where she started? So we need to find this distance between where she started and where she ended up back on the road. So we're looking for y here. We can just set up another law of sines ratio if we would like to. Y corresponds to 105. And then we still have 450 corresponding to angle 40. So we could say y over sine of 105 equals 450 over sine of 40. If we multiply by sine of 105 to cancel here, let's go do that in our calculator. 450 times the sine of 105, oops, helps if you type it all in there, 105, divided by the sine of 40. And now we know that she ends up 676.221 meters further down the road from when she left the road to begin with. Okay. So honestly, on that one, we could have used either law because we had enough for either one. If you wanted to go through and solve it using law of cosines, you could have done that. I just think it's a little bit easier to set up this ratio for law of sines, but it's completely up to you. You should have ended up with the same answer no matter what. Okay. Guys, again, just as a basic guideline for these problems, make sure you draw a picture, okay, and label it. And then take a look at what you have to see what law you could use in order to solve. Okay, remember for law of cosines, it's side, 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 or side, angle, side. For law of sines, it's everything else. Okay, anything else you could use law of sines for. Okay, we're going to do a lot of practice with these types of problems. Please feel free to reach out to me if you have questions.